Okay, question 12, we have an exponential model. So the value v pounds of a vintage car 10 years after it was first valued on the 1st of January 2001 is given by v is equal to a p to the power of t, where a and b are constants. Given that the value of the car was 32,000 on the 1st of January 2005 and 50,000 on the 1st of January 2012, A part 1 wants us to find the value of P to 4 decimal places. Okay, so what it's giving us here is two sets of values. So in 2005, T is equal to 4. It's been 4 years since 2001, and V is 32,000, and it's also giving us T is equal to 11. So we can get two equations for this. So when T is 4, V is 32,000. So that gives us 32,000 is equal to AP to the power of 4. Now we also know when T is 11, V is 50,000. So that also tells us then 50,000 is equal to AP to the power of 11. So if we call these equations 1 and 2, they are simultaneous. Now what we need is, well, we're looking for P, so we need a way to make A bugger off. So we can divide equation 1, we're going to divide equation 2 by equation 1. So that's going to give us, if we do 2 divided by 1, that's going to give us AP to the 11 over AP to the 4 is 50,000 over 32,000. Now the A's cancel each other out. We get left with P to the power 7 is, that cancels down to 25 over 16. So P is the 7th root of that fraction. So we get 1.0658. And for A part 2, they want us to show that A is approximately 24,800. So in the model where we have A and P and T, we now know that P is 1.0658. So what we're going to do here is use one of the values that we were given. So let's choose when T is 4, V is 32,000. So again, when T is 4, V is 32,000. So we now know what P is. So we get 32,000 is equal to A times 1.0658 to the power 4. Therefore, A is 32,000 over 1.0658 to the power of 4 which gives us 24,799.7 blah blah blah, which is approximately 24,800. Cool. Okay, then for part B, with reference to the model, interpret part 1, the value of the constant A. So, when t is equal to 0, v is a p to the 0, which is just a. So a is the value when it was first valued. So a is the value on 1st of January 2001. And then for part 2, the value of the constant p. So p is 1.0658. So p tells us that the value is increasing now. If we wanted to put it as a percentage, the increase part is the bit after the decimal. So 0.0658 multiplied by 100 would give us 6.58%. So it's increasing by 6.58% each year. Cool. Okay, then for part C, we want to find the year during which the value of the car first exceeds 100,000. So if we set V equal to 100,000, we will find the year during which it will equal 100,000 by the model. Straight after that, it's going to exceed 100,000. So we're going to set 100,000 is equal to 24,800 times 1.0658 to the power of t. If we divide by 24,800, then 100,000 divided by 24,800 gives us 4.03, so that is equal to 1.0658 to the power of t. Take logs of both sides, so log 4.03 is equal to a log of 1.0658 to the power of t, which by the rules of logs we can write as t log 1.0658 divide by log of 1.0658. So we have log 4.03 over log 1.0658. That is equal to t, which is going to give us 21.9. Now, that means then 21.9 years after the 1st of January 2001, the value is going to equal 100,000. So, with this type of growth, as soon as something is equal, it's going to overtake and exceed. So it's going to be in year 2022. Cool.